Hi, welcome to lesson 7.3 using triangle congruence theorems. Now, before we start with the notes, there's a couple things that I posted in Google Classroom as resources to help you, especially with this unit being very proof heavy. So in Google Classroom, you will find a post that includes the theorem section and the postulate section from the back of your textbooks. So including those two sections, the glossary or definition section of your textbook will probably be the three best resources for you as you work through these proofs. So my advice is to look in those sections of your textbook or look at those PDFs posted in Google Classroom to help you through this process. So as we look at these four different examples for notes today, keep in mind that with the proofs, there's different ways that you can organize them, go through the process. You'll see many of the examples here have the given split into different steps. The reason that they do that is just kind of the order that they go through in the book to do this process. It is more than okay if you would take, for example, here in example 1, the steps 1, 2, and 5, which are the three different parts of given information being split, and if you would just start your proof with those three all together. So it is okay to split those or to combine them, but just keep in mind always at least your first step will have to be the given for justification. And then when you're looking at your original give and prove statements, this final prove statement is always the final statement of the proof. You'll see in this one, it should say EDF is congruent to ABC, not equal to ABC. So that's missing just the little squiggly congruent sign above the equal there for conclusion 6. Now, the other advice that I have for proofs is if a proof does not include an image or a picture, to draw yourself one and to add markings to it, add symbols, indicators as you go through the steps, as you'll see that I did here as I went through these proofs. So we're going to look at these processes. Again, my advice as you do the practice problems, use those other resources, use the theorem section, postulate section, and your glossary. And again, if you miss a step or two along the way, that's the whole purpose of the practice problems. Check the odds in the back of the book as you go to see how you're doing with these proofs. Also, if you do need any other resources, help along the way, help with some of the proof steps, feel free to get a hold of me in office hours or shoot me an email and I'll get a hold of you, get you a couple of resources, see what I can do to help. So looking at example 1, we were given the idea that angle B and angle D are right angles. So the first thing I did in the diagram, I just went in and drew the right angle symbol at angle D and angle B. We also knew side BA was congruent to side DE and BC congruent to DF. So side BA and DE, I put the single congruency marker, and then DF and BC also put the congruency symbol. So then our process, what we're trying to do is eventually prove triangle EDF is congruent to triangle ABC. So they gave us, in this case, all the conclusions. They wanted us to fill in the justifications. So the first thing that they gave us, BA congruent to DE, part of the given info, as well as angle D and angle B are right angles. Then they indicated the measure of angle D equals 90 and the measure of angle B equals 90, which is the definition of right angles or a right angle. Then, by definition of right angle, if they're both 90, we can indicate that angle D is congruent to angle B. So that tells us angle D congruent to angle B is the angle congruence theorem. If their measures are equal, then the angles are congruent. And then they indicated side DF is equal to BC, or it should say congruent again. So the congruency symbols missing above 5 and 6. But DF congruent to BC was part of our given. And then if you look at the image, side, angle, side with the included side or the included angle. So side, angle, side congruence theorem using steps 1, 4, and 5 from this proof. Example 2 tells us side AB, or line AB, is parallel to line XY. So indicated with the arrow on each side. Then we were also told that segment AX bisects segment BY. So AX bisects BY, what that tells me is that YP and BP are going to be equal or congruent. So I know that's going to be part of my proof based on that idea of a bisector. Then these other markings on the angles, you'll see I added as I went through the proof. So again, they gave us most of the conclusions with a couple blanks and question marks. Otherwise, they just asked for the justifications. So in this case, again, began with the given. Then they started conclusion 2 with angle B being congruent to another angle. So what I want to look at in this case, angle B would end up being congruent to angle Y because these two lines are parallel. Those are alternate interior angles, and that is part of the parallel lines theorem. Then AX bisecting BY was part of our given. P is the midpoint of BY, would just be part of the definition of a segment bisector. That a segment bisector intersects the other segment at a midpoint. Then, by definition of a midpoint, that tells us that BP would be congruent to side PY. Then the next piece, which is the other part that I drew into the proof, we have vertical angles right here at this intersection. So they said angle APB was congruent to, and we had to fill in angle XPY, the vertical angle to that, which would be the vertical angle theorem. And then based on the information that we were drawing into the triangle, we now have an angle, an included side, and an angle. So therefore, we can state that triangle ABP is congruent to triangle XYP. So what you'll notice as we work through these, all of these proofs are going to be based on the title of this section using our triangle congruence theorems. So your answers and these final justifications should be one of the triangle congruence theorems that was introduced in the last section. Now, example 3, the indicators on the diagram get a little messy, so my apologies there because we have some overlapping segments, but no real way to avoid that. So they began with the idea that the given information in the figure at the right, both circles are centered at point O, and that segment BA is congruent to segment DC. So I went in and just indicated first BA congruent to DC. The final goal is, in this case, to prove that angle AOB is congruent to angle COD. So in this case, now we are not proving triangle congruence, but our proof will be using a triangle congruence theorem. So you'll see later on in step 5, we use the congruence theorem to prove the congruent part, which would be our final step. So again, we begin with our given that the two circles have the center of O. Then we could in this case, split it like they did into steps 2 and 3, or we could include this into one step. The reason that they split these into two different radii of the circles is because they're based on two different circles. The one is based on the smaller circle, then the other is based on the larger circle. I would be fine if you'd combine these two steps. The reason the book split them is because they're based on two separate circles. But in this case, they gave us the conclusions of OA being congruent to OC, which are radii of a circle. So definition of a circle tells us radii of a circle are congruent. Same thing with OB being congruent to OD. Radii of a circle are congruent. Then they went back to BA being congruent to DC, which was part of our given information. So based on going back in and drawing what I know at this point, when I look at this, I have side relationships, which allow me to state triangle AOB is congruent to triangle COD from those steps 2, 3, and 4 in our proof. Then one of the more important theorems that we'll be using, especially in these final steps, once we've proven congruent shapes, so triangles in this case, then we can use the corresponding parts of congruent figure theorem to state any corresponding parts in those shapes are congruent. In this case, those parts are angle AOB being congruent to angle COD. And our last example for this section, they began with giving us the information that segment KI was congruent to segment TI, and that ray IE bisects angle KIT. They would like us to prove segment KE is congruent to segment TE. So again, in this case, they gave us conclusions, many of the justifications, just a few blanks to fill in. So the first thing, which is weird that I began with this, in this case, I would not do it this way. I would flip these two steps so that we would always begin with the given. So I would start this with IE bisects angle KIT and flip that to step 1. Then step 2, we could use the reflexive property of congruence, saying segment EI or IE is congruent to itself. In that case, now we know that IE is congruent to itself. Then, based on the idea of an angle bisector, we would be able to say angle KIE is congruent to angle TIE. That's the definition of that angle bisector. So it went in and drew in that congruent angle. And then we also knew that KI was congruent to IT, giving us a side angle side triangle relationship. So we could say triangle KIE is congruent to triangle TIE. And then based on those congruent triangles, the corresponding parts, we could say that side KE or segment KE is congruent to segment TE. And that would be part of the corresponding parts of congruent figure theorem.